Yeah, so this ship behind us is the James Clark Ross. It's a ice strengthened vessel run by the British Antarctic Survey, and that's how we've gotten to be down here in the Weddell Sea. If you want to study sea ice, it's actually quite a difficult journey sometimes in that it can be very inaccessible. We've had a fairly difficult time coming down here to do our survey. We've had a several-day transit from Stanley, and actually that was through the notorious Drake Passage. It was remarkably calm, so we're feeling pretty good. But then when we got here, we had some problems with our equipment. We had the submarine going under the ice, and it got lost or got stuck. We spent about a day and a half trying to rescue that, and then trying to get here to do our survey. We got stopped by all the ice you see around you is just quite thick. It's very difficult for a ship such as the James Clark Ross to break through it, but it did a remarkable job, spending a day trying to get about a mile the other day, but here we are. We've had a successful survey here. Yesterday we had aircraft fly over us, and the submarine is under us now as we speak. So after a long journey here, we're pretty happy to be getting this done now. So what we're trying to do here is actually something quite simple. It's just measure the thickness of the ice we have around here. And it may seem simple, but it's a complicated thing. The trouble is, we have a pretty good picture of how much ice there is in terms of area, how much of the ocean it covers. That's because it's really easy to see from satellite. But of course the ice is solid, so you can't see through it really well. So we don't know how thick it is very accurately. So the purpose of this cruise and this project is to measure the thickness of the ice. Now the ice isn't just a level sheet like you have on a lake. It's also quite bumpy and ridged, and that's because it's a very dynamic environment. You have blocks of ice being pushed by winds and currents and creating these big ridges like these ones we have behind us. We can see this from above. That's kind of an easy thing. We can see that from an aircraft or from a satellite, but we can't see what's going on underneath. And that's what's so great about this project is we've got an AUV, or a robotic submarine, and it's flying underneath the sea ice right below us now, actually. And what it's doing is measuring the thickness of this ridge beneath the sea level. And so it's looking at it and doing the same thing that the aircraft is doing. It's getting a two-dimensional picture, scanning along the bottom with a sonar. And then we can see what this ridge looks like on the bottom. Well, it's important to study sea ice because sea ice covers quite a lot of the ocean, of the area of the Earth. It covers something like 7% of the surface of the ocean. And what it does in Antarctica and in the Arctic, it's very cold here. So if you didn't have the ice, the ocean would lose lots of heat to the atmosphere. So this forms kind of an insulating blanket over the ocean. And so it's regulating the exchange of heat with between the ocean and the atmosphere. And as you know, it's white, so it's reflecting the sun as well. So it's very important for the climate system.